Welcome back. In previous video I explained the center of mass and its position, velocity, accelerations. Now I'm going to discuss frame of reference and then the distinction between two kinds of frame of reference. One is laboratory frame of reference and center of mass frame of reference. Okay, first thing, what is frame of reference? The frame of reference is a reference system. It is a reference system of a coordinate axis attached to an observer having a clock with respect to which the observer can describe the position, displacement, acceleration, etc. of a moving object. The meaning is, now I am going to write the position, velocity of moving object. For that I am going to use a reference system of three coordinate axes, or if it is in space, that is x, y, z. Okay. In two dimensional only two coordinates x, y is enough. In one dimension only x axis is enough. Okay. So now there is an observer attached to this frame of reference. An observer is standing here. He has a clock to measure the time and the position, velocity of the object. Okay. Now he is at origins. With respect to this, he is going to measure the position of the object. Okay. Now if the position is here, after a certain time it moves here and then it is here. So all these movements are measured with respect to this origin, and the time is measured also with respect to that positions. Okay. Here two kinds of frame of references are there. One is laboratory frame of reference, and the one is center of mass frame of reference. These two were using in this unit. So one is laboratory frame of reference. So laboratory frame of reference means a frame of reference is attached to a laboratory. That means origin of reference system is, I am writing here, origin of reference system is a point rigidly fixed to laboratory. Okay, so that kind of frame of reference we call it as laboratory frame of reference. The position and velocity, whatever the phenomena occurring, all are measured with respect to the laboratory. The position, velocity, acceleration, so all are measured with respect to laboratory frame. So that is only in case of laboratory frame of reference. And the total momentum before collision and after collision, if there is a collision, then the total momentum before collision is equal to total momentum after collision. Okay. So here description about this laboratory frame of reference and how to measure the position in laboratory frame of reference, all are I am going to demonstrate in this class only. You can see that at the end of this class. Okay, this is all about the laboratory frame of reference and center of mass frame of reference. The definition is, the origin of reference system is attached to the center of mass frame. Okay, so that is only the difference here. The origin of a reference system is point rigidly fixed to the center of mass. Already I say what is center of mass and what is the position of center of mass, like that. So that we call it as center of mass frame of reference. Then the position and velocity measured with respect to the center of mass frame. Here position, velocity, so these all are measured with respect to center of mass frame. And here the total momentum before collision is equal to after collisions, but here there is a restriction that the momentum of center of mass is 0. It means the center of mass is at rest in center of mass frame of reference. That means velocity is 0 of center of mass. Okay. Velocity is 0 at center of mass. For that, this we call it as zero momentum frame. This we call it as center of mass frame is called zero momentum frame. So these two are the difference between laboratory frame of reference and center of mass frame of reference. Now let's see by a small demonstration how to measure the position in laboratory frame of reference and as well as in center of mass frame of reference. In center of mass frame of reference, I am going to consider two objects of same masses. For that, the center of mass is always lies between the center of the position of two objects. Okay. Now let's see that demonstration. Okay. Here I am trying to show how to measure position in laboratory frame of reference as well as in center of mass frame of reference. So in laboratory frame of reference, a frame of reference is fixed to a laboratory at a certain point. With respect to that point, we are going to measure the position of the object at different instant of time. Now I am going to show how to measure the position in laboratory frame of reference. Now this is our laboratory. Here we are going to measure position of this object at different instant of time. Initially this object is here. Now it is moving in this direction. Just I am taking one dimensional motion. So if it is moving, now how much distance it covers, don't know, because we have to measure with respect to certain lengths. Okay? Then only you can say that this object moves this much of distance. For that we have to use frame of reference. So one of that is laboratory frame of reference. Now I am going to take one dimensional frame of reference. So just taking this scale to measure the position of the object at different instant of time. Now, okay, wherever you place this laboratory frame, okay, first I place this at 1 centimeter, 0 centimeter. So now this reference point is now it is origin. With respect to that reference point, we are going to measure the positions. Now it is here, it is at origin 0 centimeter. Now it starts moving. So it maybe comes here after certain time interval. So now it is at 12 centimeter. How we can say? Now we can refer the frame of reference that is fixed to the laboratory frame. I am not going to change I am not going to disturb the reference system. Just I am going to fix that to the laboratory only. Now only changing is object motions. Okay. Now it is moving. It comes at 18 centimeter, and again it is moving. It comes at 26 centimeters. So again it is going like that. So with respect to that laboratory frame, we can measure the position. This is one dimensional motion. Okay. So usually in every laboratory we are going to use laboratory frame of reference. So another kind of frame of reference is center of mass frame of reference. Okay. Here in center of mass frame of reference, we are going to attach a frame of reference to the center of mass. Where the center of mass is there, at that position we are going to attach the frame of reference. With respect to that, we are going to measure. Now here I am taking center of mass frame of reference. So here also considering one dimensional motions. Now there are two objects. These are the two objects. The center of mass of this object is here. Now, so I am going to take these two objects at different positions. Okay. So one is at 1 centimeter, and then is what it is at 38 centimeters, somewhat nearly 40 centimeters. Now whatever the change in position of these two objects, okay, now the position of these two objects is changes, but the center of mass is not changing. The position of center of mass is not changing because that is fixed to the frame of reference. That's why we call this as center of mass frame of reference. Now see here, I am going to change the position of objects. Okay, when the object is moving, center of mass is also moving along with the reference frame. Okay. So this is what we call it as center of mass frame of reference. Now compare these two. These two means one is laboratory frame and then is center of mass frame. Here I am going to bring laboratory frame of reference near to this center of mass frame of reference. Okay. So and then here it is laboratory frame of reference, and this is center of mass frame of reference. Okay. Now compare these two. Okay, so these two are the position of objects in both laboratory frame as well as in center of mass frame. In laboratory frame of reference, the position is at 1 centimeter and about 35 centimeters. In center of mass frame of reference also it is 36 and 34. Now I am going to change the position of the object. I am going to change only one position of the object, which is this one. Okay, now changing the position. What is the new position in center of mass frame of reference? So now it is here, it is 31 centimeter and this is at 6 centimeters. Okay, in center of mass frame of reference, the position of center of mass is remains same. There is no change in center of mass frame of reference. Okay, the object position is changes. Now compare this with laboratory frame of reference. Initially these two positions are at 1 centimeter and 38 centimeters. Now one object remains at the same positions, another object now changes to 26 centimeters. Once again see here. Okay. And what is the position of center of mass? It is at 20 centimeter in laboratory frame of reference. Okay. Now in laboratory frame of reference, the center of mass position is also changes and one of the object mass position is also changes, but here this position remains at rest in laboratory frame of reference, but in center of mass frame of reference the position of those two objects is changes and the position of center of mass remains constant. So like this we are going to measure the position of objects in center of mass as well as in laboratory frame of reference.